So this is going to be part 2. If I look at the problems, they're not going to be remarkably different than the problems we did in part 1. Each problem has a system of two. It has two equations that would graph to be lines, and we're trying to find out if the lines meet in one point, if the lines are parallel, or if the lines actually are the same lines. And now we're going to solve the problems by something called the substitution method. And some students won't go beyond this, and they won't learn the next skill that we're going to learn. And substitution method is not my favorite. And if you don't learn the next method, you're going to create a lot of work for yourself. The substitution method is a method for solving systems of equations that is beautiful if one of the equations is solved for x or if one of the equations is solved for y. If you're given a system of equations and neither equation is solved for x or solved for y, substitution method is a poor choice. But let me try to describe what the substitution method is. It has steps, and maybe I'll write those steps on a separate sheet of paper so I can have them handy as we go from problem to problem. So if it's not already done, the first step in the substitution method, the way to solve these systems without graphing one of the two ways, is going to be solve one of the two equations for either x or y. You can't solve for both. It doesn't matter which one, but it's gonna matter because one of the choices won't lead to fractions and the other will for some of the problems that are coming up. And I'm going to say, I'm going to choose so that I avoid fractions. The first few problems, this is already done for me. So I'm going to solve one of the two equations for either x or y if it's not already done for me. In the problem I'm about to do, the top equation is solved for y. That's having one of the two equations solved for either x or y. It's done for me. Second, I'm going to substitute into the other equation. Or the opposite equation might be a better word. Let me do that first step for this problem. So step 1 was not necessary. Step 2 is I'm going to substitute, very specifically, I'm going to substitute 2x minus 12 in for the y, because the first equation tells me that y is equal to 2x minus 12. That means I can do that substitution. So the first step that I would need to do for problem 8 would be to replace the y with 2x minus 12. And I leave everything else the same. Step 3 is solve this equation. I can't say for x or y because sometimes I'm going to be solving for x, sometimes I'm going to be solving for y depending on what substitution I did. Oh, you moron. Solve this equation. So I'm going to clear the parentheses, combine like terms, get the letters on one side, the numbers on the other. Numbers are getting big, I might need a calculator. To clear the parentheses isn't going to impact the 3x that's out front, but when I go negative 8 times 2x, I'll get negative 16x. And when I do negative 8 times negative 12, I'll get positive 96. So the stuff that we learned in section 2.1 comes back here hardcore. Now on the left side, I'm going to combine the 3x minus 16x and get a minus 13x. Still in the step 3 here of taking the algebra to solve this equation that I created. Now I'm going to minus 96 from both sides. It gives me minus 13x equals, I think, minus 91. I'm dumb if I'm not using my calculator in this section, otherwise I'm going to wind up recording this video again. And now I'm going to divide by negative 13, divide by negative 13. This is going to give me x equals, and then negative 91 divided by negative 13 gives me 7. The variables didn't drop out, so this is the common situation where you get one answer. Done with step 3. And now I'm going to solve for the opposite variable. I have an answer for x, I need to get an answer for y. It turns out that I can use any equation that exists in this problem to solve for the opposite variable, but I might as well use the equation that solved for y. I can use any equation, but to solve for y, the equation y equals 2x minus 12 just makes sense to use because it's already solved for y. And what I'm going to do is I'm going to plug the answer that I just figured out into that equation for the x and do the algebra. And I get y equal to 2. And so now the answer to this is just the single point. If I were to graph these two lines would intersect at the point 72. I'm done. It's wise to check. I'll say it's optional, but I'm going to check most of these, but it makes the video so long too, so I might not check all of them. How do I check? Just like I did up front. In the first equation for my checking, I need to plug in x equal to 7 and y equal to 2 and make sure I get a true statement. So let me plug y equal to 2 and x equal to 7 into the top equation, and I'll do the algebra. I have to get a true statement. If I don't get a true statement, I have a mistake. It's not enough just to check the top equation. I also need to check the bottom equation by plugging in 7 for x and 2 for y. If I'm going to check, I'm going to break my calculator out, otherwise it's going to take all day. So 3 times 7 minus 8 times 2 gives me 5 on the left side, and I have 5 on the right side. So I've checked, I can put a check mark, and I'm completely done. So I did all the steps I needed to do. Your problem should work very similarly. And we'll move on now and do problem 10 and see where this takes me. So problem 10, the top equation isn't solved for x, the top equation isn't solved for y, nor is the bottom equation solved for x, nor is the bottom equation solved for y. So now I need to pick an equation and solve it for y. If I notice an equation that has a variable with a 1 in front of it, I'm going to pick that equation and solve it for that variable. Solving the top equation for x is just going to be one step. Because there's not a number in front of the x, I won't need to divide to solve for the x. So because neither equation was solved for x, nor neither equation was solved for y, I'm locked into the first step. And the first step in the substitution method is to pick an equation and isolate and solve for a variable. And anytime there's a variable with a 1 in front of it, that's the variable I'm going to isolate. So I added 3y to both sides. And now I've solved one of the two equations for x that's good enough for my first step. I'm going to move on to my second step and sub into the opposite equation. So for the x in the opposite equation, I'm going to put in a 3y plus 1. So I'm going to substitute 3y plus 1 in for the x in the bottom equation. There's my step 2. Now I'm going to solve this equation. I need to pull this sheet away because this is involved. So I'm going to do 5 times 3y to clear the first parentheses and get 15y. 5 times 1 to finish clearing the first parentheses and get 5. So I'm left with 15y plus 5y plus 8y equals 51. I'm going to combine the 15y and 8y, which will give me 23y plus 5 equals 51, minus 5 from both sides will give me 23y equals to 46, and then divide both sides by 23. You should be using your calculator if you can't do the arithmetic in your head. That will give me y equal to 2. That's the end of step 3. Now I need to solve for the opposite variable. Here I have an answer for y. I need to get an answer for x. I can use any equation. This is the go-to equation here probably. It's the easiest one to solve for x. But any of the equations for this system are permissible. They'll all give the same value for x. So I get 7 for x and 2 for y. I claim that these two lines, if I were to graph them, would meet in a single point. And my solution is going to be 7, 2. I should check. So for checking, I should go to the top line, change the x to 7 and the y to 2, and make sure I get a true statement by going 7 minus 3 times 2 to simplify the left side. Confirm that that's true, and do the same for the bottom equation. In the bottom equation, the 5x plus 8y equals to 51. Plug in 7 for x and 2 for y, and make sure you get a true statement. And if I'm going to check, I'm just going to press buttons because of the time factor. So because it works in both equations, I will say I'm good and my answer is correct. (11) and 12 are awful. Let's do 11 together. I usually won't do the substitution method if I see fractions, but I'm going to. So we're going to work on 11 as opposed to 12. Step 1 is solve one of the equations for x or y. If it's not already done, it's already done. In number 11, the top equation is solved for x, so I don't need to do step 1. It's already done for me. Now I'm going to substitute into the opposite equation, which means the y in the second equation, oh my lord, I'm going to change to minus 5. Yuck. So I'm going to write the second equation as 4x minus 5 times 3 halves x minus 7 equals to 28. Well, let me worry about this. I need to clear the parentheses. I need to do minus 5 times 3 halves x and minus 5 times minus 7 to clear that parentheses. I'm going to bring down the 4x, and now I'm going to do minus 5 times 3 halves. That's going to give me minus 15 halves x. So this should be 4x minus 15 halves x. And then that I can do without a calculator. That's plus 35. And then equals to 28. I need to combine the 4x minus 15 halves x. And I do that by doing 4 minus 15 halves. 4 minus 15 halves is negative 7 halves. So I'm going to write this as negative 7 halves x plus 35 equals to 28. Really going to rely heavy on my calculator for the fraction so I don't make a mistake. Now I'm going to minus 35 minus 35. On the left-hand side, when I minus the 35, I'm left with a minus 7 halves x. On the right-hand side, I'm left with a minus 7. To solve for the x, I need to multiply by its reciprocal. So I'm going to multiply the left side by minus 2 over 7, and I'm going to multiply the right side by minus 2 over 7. On the left side, multiplying a number by its reciprocal, you get 1. So it's just going to leave me with a 1x. And on the right side, when I multiply negative 7 times 2 over negative 2 over 7, I get positive 2. So that's part of my answer. Part of my answer is x equal to 2. This is finishing step 3, solving this equation using heavy technology. Now I need to do step 4, solve for the other variable. And I don't know if I want to deal with that equation. I don't like fractions, so I'm going to worry about not using that equation because I could use either. I'm going to use 4x minus 5y equals to 28 and plug in 2 for x. I'm going to go 4 times 2 minus 5y equals to 28, which will give me 8 minus 5y equals to 28. Then I'm going to minus 8 minus 8. That will give me minus 5y equals to 20. Divide by minus 5. Divide by minus 5. And get y equal to negative 4. That's really a surprising solution to me. That's not my standard solution to a problem like these. I don't have a lot of negative solutions in general. But I think it works. So I'm going to say that the answer to this is x equal to 2, y equal to negative 4. Let me calculator check. So I'm done with the solving. Now I'm just into checking. I'm going to start by using y equals 3 halves x minus 7. I'm going to plug negative 4 in for y and positive 2 in for x. And I'm going to simplify. I'm going to see if 3 halves times 2 minus 7 gives me what I need it to give me. And it does just perfectly. When I plug 2 in on the right-hand side and negative 4 on the left-hand side, I get a true statement. I'm next going to check 4x minus 5y equals 28 by plugging in 2 for x and minus 4 for y. And I'm going to make sure I get a true statement. So if I do 4 times 2 minus 5 times negative 4, that gives me 28 equals to 28. So I know my answer is correct because I've checked it in both equations, and that's what I should do every time. All right, 14, I have to be clever. I have to do step 1 because neither equation is solved for x and neither equation is solved for y. When I have to solve for a variable and none of the variables have 1s in front of them, I look at the smaller numbers. In problem 14, the smallest coefficient is 5. In the second equation for problem 16, the smallest equation is 6. I'm going to ignore the bigger coefficients, and I ask myself, in the bottom equation, can I divide each of the numbers by this 6 and avoid fractions? If I can, I'd pick that equation and I'd solve it for x. I'd ask myself the same question in the top equation. Can I take that top equation and divide every number I see by 5 without getting a fraction? If that answer is yes, I can divide every number in the top equation by 5 without getting a fraction, then that's the variable I'm going to solve for in the equation I'm going to use. And dividing the 5, the negative 10, and 5 by 5 in the top equation won't produce a fraction. Solving the top equation for 5 is the very best thing to do for number 14. So for my step 1, I need to pick an equation and pick a variable to solve for. I always look for the smaller coefficients. And then after I pick the smaller of the coefficients, I figure out if either one of them has a coefficient that's going to avoid fractions. This is going to be new math for us because we haven't done this yet. I'm going to go through and divide each term by 5. The first one, I'm going to divide the 5s out and be left with an x. In the middle, I'll do 10 divided by 5 and get a 2. I'm going to leave the minus sign and leave the y. And then to the right of the equal sign, I get a 1. Now I have a 1 in front of the x. That's my goal, but I need the x to be isolated, so I'm going to add 2y to both sides. That's pretty heady math for a Math 115 class. But the logic's important. The reason I decided to not use the bottom equation and to use the top equation was specifically because, first of all, I ignore the larger coefficients. Those will always produce fractions. Then I look at the smaller coefficients. I look at the 6 in the bottom equation. I say, is 9 divided by 6 a fraction? If it is, I don't want to divide by 6. And then I went to the top equation. I said, well, is 10 divided by 5 a fraction? No. Is 5 divided by 5 a fraction? No. Well, then I'm going to use that equation. So that's done with step 1. Now I'm going to substitute into the other equation. Very specifically, I'm going to go to the bottom equation and change the x to 2y plus 1. So I'm going to go 6 times 2y plus 1 minus 9y equals 15. This is going to give me 12y plus 6 minus 9y equals 15. And now I'm going to do 12y minus 9y and get 3y plus 6 equals to 15. And then minus 6 minus 6. That will give me 3y equals to 9. And then divide by 3 gives me y equal to 3. And now I'm going to solve using x equals 2y plus 1 and plug in 3 for y. That's going to give me x is 6 plus 1, which gives me x equal to 7. The answer to problem 14 is x equal to 7, y equal to 3. Boy, I'm so far from done, and I'm at 25 minutes. It's going to have to be like a 5-part lecture because I'm doing so many problems. So Let's do 16. I'm going to make a part 3. There's going to probably be a part 4 and a part 5. I'm so sorry, but that's just the way this is going to be. So when I look at 16, I ask myself, is either equation solved for a variable? No. Does either equation have a 1 in front of a letter? No. So I look for the smaller letters. In a bottom equation, the smaller coefficient is 2. Is 5 divided by 2 a fraction? Yeah, it is. I probably don't want to use that. Go to the top equation, ignore the 6, look at the smaller number 3. Ask myself, is negative 6 divided by 3 a fraction? No. Is 6 divided by 3 a fraction? No. For step 1, I want to take the top equation and solve it for x. So I'm going to start off with my top equation and divide through by 3. And that's going to give me x minus 2y equals to 2. And now I'm going to solve for x by adding 2y to both sides. This is going to give me x equals 2y plus 2. That I'm going to substitute into the opposite equation. So I'm going to go to the bottom equation and change the x to 2y plus 2. I'm going to leave the plus 2y and I'm going to leave the plus 22. Clear the parentheses that I put in to get 10y plus 10. Leave the plus 2y, so not plus 22, it should be equals 22. Combine the 10y and 2y and get 12y. Leave the plus 10, still equals to 22. Then minus 10 minus 10. So give me 12y equals to 12. And then divide by 12, divide by 12. Gives me y equal to 1. I'm going to substitute into that equation to solve for x. I'm going to go x equals 2 times y plus 2. That gives me x equals 2 plus 2, which gives me x equal to 4. I claim the answer to number 16 is the 0.41. I could check it. I have answers at my fingertips, and that is the right answer. I'm going to save the time and not check it. I'm going to pause the video and we're going to do the problems that have parallel lines and lines that are on top of each other in a part 3. And we haven't even got to the other method yet, so there's likely to be a part 4 and a part 5. Ugh.